We've already discussed quadratic functions briefly. We've introduced the idea. And in this section, we're going to talk a little bit more about specifically the standard form of a quadratic function. So if you remember what we talked about in class the other day, we went over both the standard form of a quadratic function and the vertex form of a quadratic function. Later in this chapter, we're also going to talk about a third form of a quadratic function, which is the factored form, but we won't be looking at that in great detail for another couple of sections. So let's just take one more look at what these equations look like. The standard form of a quadratic function is just that f of x equals ax squared plus bx plus c. And again, that's the form that we're going to be focusing on in today's video. We've also talked about the vertex form of a quadratic function, which would be f of x equals a times the quantity x minus h squared plus k. Now we know that the vertex form of a quadratic function is handy because you can very easily pick out what the coordinates of the vertex will be given an equation in vertex form. The x-coordinate of your vertex will be h, the y-coordinate of your vertex will be k. So you get some information about the shape of the parabola and where the vertex is immediately just by looking at the equation. We can still get this information from a quadratic function given to us in standard form, but we have to look a little bit harder. It's not quite so easy as just looking at the equation and being able to pick out the x and the y coordinate of the vertex. So let's take a look at the standard form of a quadratic function specifically and talk a little bit about the different information that we can get from this equation. We talked about a previously and what that coefficient on x squared tells us, and it's no different if your equation is written in standard form or vertex form. In either case, if a is greater than 0, so if a is positive, your parabola opens up, and if a is negative, so it's less than 0, your parabola will open down. And just recall that if it opens up, that's going to mean it looks like it's a smiley face, I guess. And if it opens down, it looks like a frowny face. The axis of symmetry for your parabola, if it's written in standard form, can be found by taking a look at your coefficients a and b. The equation for the axis of symmetry is always going to be the line x equals negative b over 2a. Now that relationship negative b over 2a is something that you're going to want to commit to memory. On page 203 in your book, your textbook goes through an explanation of where that expression negative b over 2a comes from and why it is going to be the x-coordinate of both our vertex, and it gives you the equation of the line of symmetry. So since we know where the axis of symmetry in our parabola occurs, it occurs at the x value negative b over 2a, that means we can figure out where the vertex occurs. The x-coordinate of our vertex will be negative b over 2a, of course. And then the y-coordinate, see if I can scrunch it in here, will be the y value of our function evaluated at that x value of negative b over 2a. That notation might look a little bit intimidating, but we're going to go through a couple of examples that will show you what exactly that means. The last piece of information that we can get from a quadratic function written in standard form is what the y-intercept is. Remember that the y-intercept for any function, whether it's linear, quadratic, cubic, no matter what, is just the point, it's the y value that you get when your x-coordinate is 0. So let's take a look up at our standard form of our equation. If we plug 0 in for x, we're evaluating f of 0, of course. So that would be a times 0 squared plus b times 0 plus c. So of course the first two terms cancel out because anything times 0 is just 0, and you're just left with c. So what that tells us is that for any quadratic function written in standard form, we automatically know that the y-intercept is going to occur at the point 0, c. Of course, the x-coordinate of a y-intercept is always 0 by definition, and then the y-coordinate is just that value c that shows up in your quadratic function in standard form. So c is sort of like b in slope-intercept form back when we were talking about linear equations. So let's do a couple of examples. Our first example says, describe the graph of y equals negative 2x squared plus 2x minus 5. So first of all, we want to recognize that this is a quadratic function given to us in standard form. So that means we know that we have this a coefficient here, we've got our b coefficient on x, and then the constant term is our c value. So let's go through exactly what we laid out on the last slide and see what we can state about this particular quadratic equation. First of all, let's look at our value of a. A is negative 2, and that tells us that because negative 2 is negative, that our parabola must open down. So that's one thing that we can say. Now, let's go on to talking about our axis of symmetry. We know that the equation for our axis of symmetry is going to be x equals negative b over 2a. So all we need to do is plug in our a and b coefficients into that expression. So that means for our particular equation that we're looking at, b is positive 2, and so of course the opposite of positive 2 would be negative 2, so negative b will be negative 2, over 2 times a, and in this case a is negative 2, so we're going to plug that in. And so we're left with negative 2 over negative 4, which of course simplifies to positive 1/2. So that was a little sloppy over there. I'm going to copy this back down. So that means that our axis of symmetry occurs at the line x equals 1/2. So the last thing that we need to do, actually we have 2 more things, excuse me. We still need to talk about the vertex, and we need to talk about the location of the y-intercept. So let's do the vertex first. And notice that to get our vertex, we've already figured out what the x-coordinate of our vertex is. That's going to be the same value that we got for our axis of symmetry. So our x-coordinate of the vertex is going to be 1/2. We just calculated that. What we need to do now, though, is figure out what the y-coordinate of our vertex is. So since we know that x is 1/2, we're going to plug that value for x into the equation for our parabola. So let's see. I'm going to jot something down over here, and just so this doesn't get too sloppy, I'm going to do this calculation on another slide. So we know that the x-coordinate of the vertex is 1/2. Remember, we just got that. And then our equation, let's see, y equals negative 2x squared plus 2x minus 5. So now all we need to do to get the y-coordinate of our vertex is take this value of 1/2 and plug it into our equation everywhere we see x. So we're going to get y equals negative 2 times 1/2 squared plus 2 times 1/2 minus 5. Now 1/2 squared, you have to think about how to work with exponents here. I'll do a little refresher up at the top of the slide. We have 1x squared. Properties of exponents tell us that we need to apply that exponent to both the numerator and the denominator. So we're going to square 1 and we're going to square 2. Well, 1 squared is just 1, so our numerator stays as 1. But our denominator is now 2 squared, which is 4. So 1/2 squared is 1/4. So heading back down here, we've got -2 times 1/4 plus 2 times 1/2. Remember, to multiply fractions, you multiply your numerators together and multiply your denominators together, so this becomes 2/2. And then minus 5. So we just need to simplify a bit. -2 times 1/4 is -2/4. 2/2 is just 1. We still have minus 5. I'm just about to run out of room. -2/4 is, of course, 1/2 plus 1 minus 5. So now we just have to combine all those terms together. Well, -1/2 plus 1 is positive 1/2. And then positive 1/2 minus 5 would be -4.5, -4.5. So that is the y-coordinate of our vertex. So let's go back and enter that information here. We know that our x-coordinate is 1/2, and we know that our y-coordinate is -4.5. And then the last piece of information that we want to discuss about our quadratic function is the y-intercept. And this is probably the easiest piece of information to get. All you have to do to get the y-intercept is look at your constant term in the function, which is c, and that's -5, which immediately tells us that the y-intercept is the point 0, -5. So now we have completely described the graph of our quadratic function. We've gotten a bunch of information from it without even having to graph it. So let's do one more example. This one says that we want to write the function y equals -x squared plus 4x minus 5 in vertex form. So the first thing we're going to need to do, of course, if we're going to write this in vertex form, is we're going to need to identify what the vertex is. Now in subsequent lessons we'll talk about how to go from factored form to vertex form, but since we haven't talked about the factored form of a quadratic yet, you don't need to worry about that. For right now, you just need to worry about how to go from standard form to vertex form. So let's figure out where the vertex occurs. First of all, we need to figure out where the x-coordinate is, and that's going to be at the value of -b over 2a, which for this particular parabola, -b will be -4, and then a, since we've got that negative sign in front of x, of course that means that a is -1, so I'll plug that in for a. So we've got -4 over -2, which simplifies down to just 2. So the x-coordinate of our vertex is 2. Now we need to plug that value for x into our equation to get the y-coordinate of the vertex. Now I do want to point something out to you, because this is an easy mistake to make. You have to be very careful when you're working with exponents and there's a negative sign involved. Notice how I wrote this first term here. I wrote negative and then a 2 in parentheses squared. And that's because you have to think about the order of operations. The order of operations tells us to take care of exponents before we take care of multiplication. And remember that this negative sign out front, that really just means that we're multiplying by -1. So because exponents come first, I need to take care of squaring the 2 before I make it negative. That's going to give us a different answer than if I said, oh, I have -2 and I'm squaring it. Because of course, this here, what I just wrote, -2 squared is -2 times -2, which is +4. But that's not actually what we want. What we want is to square 2, 2 squared is 4, and then make it negative. So of course this is -4, and then 4 times 2 is 8, minus 5, and let's see, actually I'm going to put this over here. -4 plus 8 is +4, and +4 minus 5 is -1. So we've now identified the coordinates of our vertex. The x-coordinate is 2, and the y-coordinate is -1. So let's just write the general form for vertex form. It's y equals a times the quantity x minus h squared plus k. So we've just identified what h and k are. H is the x-coordinate of the vertex, k is the y-coordinate. So we can fill in some information pretty quickly. We know, like I said, we know that h is 2, so this is going to be x minus 2 squared plus k, but since k is negative 1, it's actually going to be minus 1 here. Now the only piece of information that's missing from our equation, of course, is the a value. And conveniently enough, the a value in vertex form is exactly the same as the a value that you get in standard form. So if you look back to our equation in standard form, I've already circled what a is. It's that negative 1 there. So we'll just need to add a negative sign out front to our equation in vertex form, and we're finished.